Good morning. I hope everybody's doing well. We're going to go ahead this morning and we're going to talk about inscribed angles. It's the first of two videos that you guys will have this week. It's your last two videos, your last two assignments. So we're going to talk about inscribed angles today. We're going to talk about secant and tangent segments tomorrow. And then that'll be the end for you guys for secondary math 2. If you guys get all the assignments done, once you guys get them done, you guys can send me an email, or next week I'm going to go through and look at all the grades and I'll go through and do all the grade bumps. So let's go ahead and let's jump into circles. We're going to talk about inscribed angles today. I'll tell you guys what an inscribed angle is. And then we're going to go through and just do a couple of problems. I just want to go through and show you guys the type of stuff that I'm going to ask you to do in the homework. Again, I'm not going anywhere near as in depth with this as we would if we were in class, okay? So with a circle, when we're talking about inscribed angles, an inscribed angle is an angle whose vertex falls on a circle. Now, when we say that its vertex falls on a circle, remember the vertex is the point where the two rays or the two endpoints meet. So if we had a circle like this first one here, and we thought about having points P, Q, and R, this angle would be an inscribed angle. And I missed Q, but that's okay. But this angle PQR, would be an inscribed angle because this point Q is the vertex right here. That vertex is on the circle. They don't always look exactly like that. Sometimes we might have tangent segments, so segments that just come up and barely touch against a circle like that. We called that point S, and our letters are going to look weird here, but we could go through and we could put it doesn't matter, A there. We'll go ahead and put a B down there. So if I wanted to talk about angle ASB, this angle ASB is also an inscribed angle. So we could say that angle ASB is an inscribed angle. And again, it's inscribed in that circle because the vertex, this point S, is on the circle. It doesn't matter that the other point B falls outside. So same thing over here. We said that angle PQR was an inscribed angle. Inscribed. And it doesn't even matter. It doesn't have to just be one angle, guys. We could have like a parallelogram. And that's not a very good parallelogram. But we could have a quadrilateral inscribed in a circle. And if we looked at that, we went J, K, L, M. All of those angles are actually inscribed. So we could say that angle JKL is inscribed. Angle KLM. KLM is going to be this angle LMJ, and angle MJK. So all four of those angles are actually inscribed angles. Anytime you guys have an angle whose vertex falls on a circle, that's going to make it an inscribed angle. Why are inscribed angles important? Inscribed angles are important because we know the measure of an inscribed angle is half of its intercepted arc. And we'll talk about what that means in just a second here. Oop. So the measure of an inscribed angle is half of its intercepted arc. What are we talking about there? If I look at this angle up here and we look at this one we drew, I've got this angle and I'm going to go over it in purple. I've got PQR here. So PQR is an inscribed angle. It's intercepted arc. The intercepted arc is the arc on the outside of the circle that goes along with that angle. So if I was going here and looking at that, this arc PR goes with the measure of the angle, or goes with the inscribed angle PQR. So we know that the measure of this angle is half the measure of the arc. So I could say here that the measure of angle PQR is 1/2 the measure of, and that's not an angle, that's the arc PR. So the measure of angle PQR, the measure of this angle here on the inside, this angle is going to be exactly 1/2 of the measure of the arc. Same thing true over here. Measure of this angle ASB, I'll do this one in green, but I've got ASB here, is going to be half the measure of the arc. Now, a lot of the time on these, they're going to go ahead and they'll put another point out here. I'm going to call it P. But so in the second one, I know that the measure of the angle ASB has to be 1/2 the measure of the arc that it intercepts. The intercepted arc is the one that comes around. So your intercepted arc is there, and they're going to call that APS. So the measure of the angle is always half the measure of the arc. If we were in class, one thing that I would tell you guys is to remember this. If they give you the angle, measure, multiply by 2 to get the arc. And if the opposite is true, if they give you the arc, you're going to divide by 2 to get the angle. Anytime, guys, you guys have an inscribed angle. An inscribed angle is an angle whose vertex is on a circle. If you guys have an inscribed angle, the measure of the angle is half the measure of the arc. So if they give you the measure of the angle on the inside of the circle, you guys are going to multiply to get to the outside. If they give you the measure of the arc on the outside, you're going to divide to get back in. I'm going to go through and I'm going to show you guys how to use this. It's really easy, guys. We're going to actually do problems right off the homework. So I'm going to grab ones that look like that, and then we'll go from there, okay? So I went through and I put your assignment together earlier. If you guys look at here, there's not a lot of people doing anything anymore. I think Jade's the only one doing circle stuff anymore, but we'll see. Let me preview here. Looks like it's 6 questions. Okay, guys. So this first one, it says find the value of each variable for the circle the dot represents the center. So I don't want to use these exact numbers, but I've got the idea of what's going on here, and we can look at it and go from there. Okay, so we're going to do an example here. And we've got a circle. And we are going to inscribe a quadrilateral. So let's go 1, 2, 3, 4. So when we inscribe a quadrilateral, again, we're putting it inside of a circle. And then when we did this one, they gave us the 2 angle measures on the right, and they gave us an arc over there. Okay. So let's go ahead and say that this one is 102. And we're going to say that this one is 80 degrees. And then let's go ahead and say that this part over here is, I'm trying to look at what portion of a circle that would be. This is going to be the C. Let's call this about 42 degrees. I'm just making up numbers here, guys. So hopefully this all works out, but I just shouldn't have any problems there. And they wanted us to find the 4 arcs. Okay. So they wanted us to go through and define this part, this part, this part, and this part. So we need to find A, B, C, and D. These are going to be related to inscribed angles some way, okay? So we're going to find A, we're going to find B, we're going to find C, and we're going to find D. I think the easiest way to go about this would be to start with the information given, and let's see what we can do with it, okay? Now, they gave me this angle right here is 80 degrees. So I know that angle is 80 degrees. What I want to do is I want to figure out what that means. So if this is 80 degrees, what that means is that the arc on the outside that is intercepted by that angle has to be double 80 degrees, okay? So as I look at this angle right here, and I'm going to use colors, if I come out on that side, and then I come out on that side, I'm going to get the arc that's intercepted. The arc that's intercepted is going to be from right here all the way around to here. So that intercepted arc goes from there to there. Now I know that that intercepted arc has to be double the measure of the angle. If they give you the angle, you multiply by 2 to get the arc. If they give you the arc, you divide by 2 to get the angle. So this is 80 degrees right here. So if I go through and do 80 times 2, I'll get 160 degrees. So I know this whole arc is 160. But there's a problem. This whole arc is made up of this arc and that arc. But I know this arc over here is 42. So if we subtract off that 42, 160 minus 42 gives you the 118. So I know this part on the outside is 118. Okay? We're going to use the exact same idea to find the other part. So to go around on the outside, we're going to do the exact same thing. And instead of using the 80 that's right there, we're going to use the 102. So I'm going to change colors really quick here. If I use the 102 and I look there and there, now I know that goes from here to here. And I know my diagrams aren't drawn to scale, guys. If they give you the angle measure, multiply by 2 to get out. 102 times 2 is 204. Well, I know 42 of it, again, is over there. So if I subtract that 42, now I get 162 there. So I know that this part going from this point right here to this point D is 204. So I know that leaves 162 right here. Well, that actually didn't help me find anything, right? But I really just need to find this portion A. That's the only portion that's left in the circle. So I know I'm drawing all over this thing. But I've got I got this part on the top is 162. I got that next part is 42. I've got the other side is 118. When I add all those up, I've got 322. But I know there's 360 in the circle. So 360 minus the 322 has to leave us with 38 degrees. So I know A is 38. I know B was 118. I went through and found those. Now they just asked us to find C and D. Once I've got the arcs, we really can go back and we can work from there. Now this diagram looks terrible because of the way I've drawn it. But C, you guys think about it here, that angle C, let's find the arc that goes with it. It comes out here and it comes down to here. So I want A and B put together, right? So if I think about this part from right here all the way down around, that's the 118 plus the 38, which is 156. Now this time I've got the measure on the outside. So when they give you the measure on the inside, you guys multiply by 2 to get out. When they give you the measure on the outside, you divide by 2 to get back in. So 156 divided by 2 gives you guys 78. So I get that C has to be 78 degrees. Once you've got that, we can use the same idea for D. If you guys come across here, D goes from here to here. So it's a 38 plus the 162, which is 200. So half of that should be 100 degrees. The other way you guys can look at it at that point is now you've got 3 inside of that quadrilateral. You know it has to add up to 360. So A, B, C, and D, the four angles inside. I'm sorry, not A, B, C, and D, but the 4 angles inside here have to add to 360. 78 and 102 is 180 plus 80 is 260, leaves you 100 for the last one. I know that might have been a little bit much, so let's look at one more exactly like that. This one, again, I'll give you guys the numbers. You guys can work through. Pretend that's a circle. You guys can go ahead, you guys can work through it and see if you guys can figure it out. And then you guys can come back and you guys can check to make sure the answers are right. So I'm going to give you guys the same values. I'm just going to go ahead and switch sides here a little bit. So let's go ahead and call this 104 degrees. Let's call this one 80 degrees. Now let's call this over here 75 degrees. And we'll go, let's A, B. They want us to find, and this will be a lowercase c you guys can find in D, okay? So go ahead, pause the video right there, go through, find A, B, C, and D for me. I'm going to pause as well really quick. All right, sorry, I'm recording in my daughter's bedroom, and she just tried to walk in, figuring out where the noise was coming from, what was going on, because she woke up. So we're going to go through here. We were going to find A, B, C, and D. Same idea as the last one. When you guys are going through, doesn't matter where you want to start. Last time I started going through and finding A and B. Let's go ahead and, or I went through, let's see, yeah. I found A and B first last time, the arcs on the outside. Let's go through and find the angles on the, oh, you know what? We can't do that yet. We have to find the arcs on the outside first. Sorry, guys. So let's go through. Let's use what we have. And let's use that to find those values on the outside again. So this inscribed angle goes from, and I'm just going to highlight the points on the outside so our circle doesn't look so bad this time. Goes from right there to right there. So I know if they give you the measure of the arc, or they give you the measure of the angle, you guys multiply by 2 to get outside. You guys divide by 2 to get back inside. So this is inside the circle. So to get the outside value, I want to multiply by 2. 104 times 2 is going to give you guys the 208. So I know the arc AB over here to this point is going to be 208 degrees. If you guys do 208 minus the 75, not 78, you get 133. So I know that this arc, all from B to whatever this blue point is here that I didn't label, has to be 133 degrees. Okay, let's keep going. If I know that this angle right here is 80, then I know the arc that goes with this angle, the intercepted arc, and again, diagrams aren't drawn to scale, but the intercepted arc there is going to have to be double as well. So from here, where my 80 degree angle is, I've got one end point there, I've got the other end point there. So I know this arc on the outside has to be, this arc from, here to here has to be double the angle. So if you guys take 80 and you multiply it by 2, you get 160. So this whole area here is 160. Again, subtract the 70. The 75, 160 minus 75 is going to give you 85 degrees. Again, not drawn to scale, guys. So I know that this arc is bigger than this one, and they've got different measures. Don't worry about that. Once you've got those three, now I know that all the arcs around the circle have to add up to 360. So if you guys go through and you add all of those up, 85 plus 75 is 160. Plus the 133 gives you 293. 360 minus the 293 gives you guys 67 degrees. So it leaves us with 67 over there. So I know that C is 85. I know that D is 67. And we use the same idea to go backwards, guys. I want to find this angle A inside, and I'm changing pen so you guys can see what we're working with here. Well, that angle goes with those arcs. So if I go through and I said, hey, I need this whole area right here, I've got 133 and 67. So those two together have to be 200. If they give you the arc, divide by 2 to get the angle. 200 divided by 2 gives you guys 100 degrees. We could use the same idea on the other side. And again, I know there's colors all over now. This thing's a big, giant colored mess. But when we're trying to go through and we're trying to find B now at that point, now that arc is right there. So I've got 85 and 67. 85 and 67 is 152. Divided by 2 is 76. So I get 76 in there. And you guys can always go back and check. Those should add up to 360. 104, 204, 274, 280, 360. So given inscribed angles, if they give you the angle on the inside, you guys multiply by 2 to get to the outside. If they give you the arc on the outside, you guys divide by 2 to get to the inside. You guys will notice you guys are going to have 2 homework problems exactly like that, okay? So I'm showing you these. You'll have those. You got a few other ones. These ones look a little bit confusing, right? But it's not that bad. So let me make sure. I think you've got 2 of those. And then a couple of easy ones at the end. So let's go through and let's look at another one of these harder ones. I'm going to actually go through and try to copy that image. So let's go ahead and let's just do this. So we're going to go ahead and we're just going to work off this screen sketch. They want us to find each of the indicated measures inside of the circle. So they gave us a bunch of inscribed angles, again, all sorts of fun stuff like that. And let's see if we can go through and find the measures of the angles and measures of the arcs, okay? If they give you guys the measure of the angle, you multiply by 2 to get the arc. If they give you the measure of the arc, you divide by 2 to get the measure of the angle, okay? So see if you guys can go through and figure these values out and then come back and check with me. All right, so let's try to do these in order and see what happens. We're not necessarily going to be able to go through and define these in this exact order, but let's see. So first thing, they want us to find measure of angle A. Oops, these pens aren't anywhere near as bright as the other ones. So we'll grab purple. So, and way too big. So they want us to go through and define the measure of angle A. If we're finding the measure of an angle, we need to find out what the arc is, and then we need to divide it by 2. So angle A is this little angle right in here. So I need to find the intercepted arc. So hopefully you guys can see that purple where I'm drawn there. Those go across there. So measure angle, or angle A has this arc on the outside, BD right here. Well, I know that that is 86 degrees, right? So if you know the measure of the arc, go back through and divide by 2. Measure of angle A then is going to be the 86 divided by 2, which is just going to be 43 degrees. So I know A is 43. I'm not going to go through and to write all these values on there. So this is measure of angle A. Later on, it might become kind of a pain to go through and to figure out where values are, but we're just going to fill everything out this way and we'll see what happens. So angle A would have to be 43. Here they want me to find the arc CE. Always a good idea, guys. Always go through and look at what you're trying to find. I'm trying to find that. And then I always think it's a good idea to go ahead and trace it back and see what you're really working with here. This is my angle that I'm working with here. So they gave me that value, right? If they give you the angle measure, you guys are going to multiply by 2 to get the arc. So when you guys are trying to find CE, I know CE is going to be 20 times 2, which has to be 40 degrees. If they give you the measure of the arc here, you guys can multiply by 2 to get the measure. If they give you the measure of the angle, you guys can multiply by 2 to get the measure of the arc. I'm sorry about that. Okay, so here they gave you the arc. We had to divide by 2 to go in and get the angle. Here they gave you the angle. We had to multiply by 2 to get the arc. If I go back and try to find C, I can look at C, okay? So angle C is right here. And that has an intercepted arc there and there. Well, they gave me that value. That's 86. So funny enough, you guys are going to notice that if 2 angles have the same intercepted arc, they have to be congruent. So this angle, angle A, had the arc BD that went with it. This angle down here, C, also has the arc BD, so they have to be the same. those are both going to be 43 degrees. And I'm going to go ahead and put it back in here again. When they ask me to find the measure of angle D, angle D is right here. Find the arc that goes with it. Goes right there. That arc is 82. They give you the arc, divide by 2 to get the angle. Last one, they wanted me to find the measure of angle ABE. Now we got to do a little bit more work, but ABE goes there. So the arc that goes with that is right here. So I have to add these two together. 82 and 40 is 122. If they give you the arc, divide by 2 to get the angle. 122 divided by 2 is 61. Going through and doing these problems with inscribed angles, guys, is just multiplying and dividing by 2. If they give you the measure of the angle, you're going to multiply by 2 to get the arc. If they give you the measure of the arc, you're going to divide by 2 to get the angle. The next two problems, the last two that you guys have to go through here, are a little bit more basic. Don't make them harder than they need to be, okay? There's another couple of them like this. When you get to here, they ask you to find the measure of the angle. The measure of the angle is half the measure of the arc. The measure of the angle is half the measure of the arc. So they gave you this angle here and they say, hey, find it. What's half the measure of the arc? Well, they gave you the arc right there. Don't make it harder than it needs to be. Same idea on the next one. So the next one, they gave you an idea here, and hint, hint, this goes right through the middle of the circle. So that tells you something about this arc length right here, the entire thing. You guys know stuff about half of a circle, and you guys can go back and find it that way. Hopefully that wasn't too long. Hopefully that wasn't too confusing. The assignment for inscribed angles is posted. It's this one right here. It's just the 6 questions. Tomorrow morning, I will post your video on secant, tangent, secant and tangent segments, and how to go through and to find their lengths. And then that's it for us this year, guys. If you have any questions, reach out and remind. I haven't been going through and even bothering to set up Schoology conferences because I had 5 of them in a row and nobody showed up. So if you guys have any questions, reach out and remind, send me an email, send me on something on Schoology. I'm more than happy to have the conferences if you guys want to. I just didn't want to go through and continue to set them up for no reason. Hope everybody's doing well. We're almost there, guys. Stick with it. Okay.